very good afternoon, sir. So now our group will commence the report for the production of Lajak Courier tablets for January. So for this report, we collected 200 random samples from 3 different shifts, which is morning, evening and night shift. The reason we did that is to see if there's any difference in production for these 3 different shifts. So we collected data on the weight, relative density, and tensile strength for each of these tablets. So we compiled our result, and this is what we got. So for the grand total for the sum of weight would be 69,917 milligram, and for the sum of tensile strength would be 1,414 megapascal, and for the sum of relative density we get 17,565%. So from this graph, we can see the difference of the 3 different shifts clearly. So for the morning shift, for sum of weight, we got 22,781. For the evening shift, we got 24,500. And for night shift, we have 22,634. So as we can see, we have a slight increase of sum of weight in the evening production. And as for the sum of tensile strength, for the morning production, we have 460 megapascal, and for evening is 494 megapascal, and for the night shift would be 459 megapascal. So same thing, we can see that the evening shift has a higher sum of tensile strength compared to the morning shift and the night shift. Whereas for the sum of relative density, morning shift would be 5,718 percentage, and for the evening shift is 6,146%, and night shift would be 5,699%. So as usual, we can see that the evening shift has the highest sum of relative density compared to morning and night shift.
Hello sir, my name is Mezatul Mahiza binti Muhammad. From the information given, we know that the Lajak Laku tablet need to follow the FDA specification by 350 mg of normal distribution with standard deviation of 14 mg. So, we have to test the data given for Lajak Laku L by doing the hypothesis test. By referring the summary table, we will not reject H0. This is because reject H0 will be if Z is less than -2.5758 or Z more than 2.575. The test statistic is -0.4185. That does not fall in the rejection region. So we will fail to reject H0. We will not reject H0 because there is no evidence to support the Lajak Laku tablets to follow the distribution and follow the FDA specification. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Yusre Eza Mahendra bin Salteh. Today, I want to explain about the answer for question C from the assignment given. So, for question C, we have examined the difference among all 200 weight for 3 different shifts, which is morning, evening, and night. We have do the statistical method to make a sum conclusion for this question. This is the statistical method we are using. In this question, we can statistically conclude that there is a significant difference between the all weight in the different shifts. Thank you.
So for the last part, it is stated that tablet's hardness can be represented by its relative density and tensile strength. studies have indicated that its tensile strength depends on the relative density, regardless of production shift. Recently, a batch was found to produce cluster of tablets that show low relative density values of 68%, 74.3%, and 80.1%. Based on the current data in January 2020, the prediction of the tensile strength for such tablets are for 68% is 5.4219, for 74.3% is 5.94543, and for the last one, which is 80.1%, is 6.42741. So the results here is based on the January 2020 data, which revolves around relative density and tensile strength, which we convert into the graph here in order to get the results for each percent, which is the value of tensile strength for low relative density. So in order to validate the model we're using in order to have the result is that we have to check three components which are, the first one is linearity, the second one is normality, and the last one is homoscedasticity. So for the first part, which is the linearity, we should check the graph of residual that is gained from the January 2020 data. So observing the graph, we can see that the data is scattered and shown no sign of pattern, and many of the data is revolves around 0.0. This shows that the model is linear, and it contributes into the validity of the data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Faid and I would like to explain the last part of our presentation, which are the homoscedasticity and also the normality part of the validity of our product. We start from the homoscedasticity part first. As we can see here, this is the distribution of the residual part of our 200 observations. For your information, sir, the residual formula is given by the value of tensile strength from the given data sheet minus with the theoretical tensile strength with which we calculated here. So based on this illustration, we can say that our prediction and our product is valid and also homoscedasticity because of the distribution of the data here shows that it is scattered without any specific pattern and the value are very close to zero with the range of plus minus 0.3 megapascal. But I want to highlight here a useful information that can be brought up in the meeting on the 3rd of July. We can see that 0.3 megapascal may not make such a difference theoretically, but when it comes to the product itself, it may disturb the quality and the consistency of our product. For example, there may going to be products that are going to break earlier before it reaches the hands of our consumers, and it is not what we want because we want to avoid losses. So I would like you to highlight in the meeting that we need to improve our consistency so that we can minimize the range of the residual below than 0.3 so that we can produce a better quality product so that our consumers will be happy. It will boost our sales and it will avoid us some losses. So moving on to the normal part, for your information again, sir, Excel cannot produce the accurate reading for the normal distribution because of the difference in scale of the Excel software itself. But we still proceed using Excel, and as we can see here from this distribution, it still produces a very obvious normal distribution line. So we can conclude from this plot that the tensile strength is normally distributed. With that, our prediction and product is valid. So, and one more, the tensile strength is normally distributed, and at the same time the residual is also going to be normally distributed. With that, we can say that all the linearity, the homoscedasticity and so the normality part of our validity shows that our product and prediction is valid.